Number 54, page 691, acid-base chemistry. In this problem, we're told we have two solutions, HBr and HI, at varying concentrations and different volumes. We are asked to calculate the concentration of all the species in the solution when the HBr and the HI mix. HBr and HI are strong acids, so that means they're going to completely dissociate. HBr will break up or dissociate completely into its ionic components, H plus and Br minus. HI will do the same thing, dissociating completely, breaking up into its ionic components, hydrogen cation, iodide, anion. Since we are given the molarity and the volume of both HR and HI, we need to convert that to moles of each chemical. Molarity equals moles per liter. The problem tells us we have a 0.05 molar solution of HBr. We want to calculate moles. We are told we have 50 milliliters, converting that to liters, 0.05 liters, solving for N. The number of moles we have in this solution is 0.0025 moles of HBr. Performing the same calculation to determine the moles of HI, you will determine that we have 0.0150 moles of HI. Now that we calculated the moles of HBr, we can determine the number of moles of each ion present in that particular solution. So since we have 0.0025 moles of HBr, and HBr is a strong acid, which means it's going to completely dissociate, we're going to end up with 0.0025 moles of H plus and 0.0025 moles of Br minus. This also is confirmed by the fact that the coefficients in front of these ions is 1. There's a 1-to-1 mole ratio. 1 mole of HBr will dissociate into 1 mole of H plus and 1 mole of Br minus. The same is true for the dissociation of the strong acid HI. HI dissociates completely into its ionic components. Since we start with 0.0150 moles of HI, it's going to break up into 0.0150 moles of H plus and an equal molar amount of I minus. So now we know how many moles of each ion are present in the solution. For the moles of H plus, we had to combine the hydrogen ion concentration from both solutions to get a total hydrogen ion molar amount as 0.0175 moles. The problem is asking us to calculate the concentration of all the species in the solution. We know the amount of moles of each ion. To determine the concentration, we need the volume of the solution that all of these ions are in. 50 milliliters of HBr was mixed with 150 milliliters of HI. Adding up the volumes of the solutions, 200 milliliters or 0.2 liters. To determine concentration, we need the equation molarity equals moles per liter. Substituting in the values, calculating, you'll determine that there's 0.075 molar solution of I minus, 0.0125 molar Br minus concentration, and 0.0875 molar H plus. Because the solutions were in water, there has to be some hydroxide ion concentration floating around. Using the Kw expression, we can determine that hydroxide ion concentration by substituting in the hydrogen ion concentration. Solving for this, you can determine that the hydroxide concentration in the solution is 1.14 times 10 to the negative 13 molar. Asked to calculate the concentration of all the species in the solution. Here are the concentrations of all the species in the solution. Any questions?